All right, hello, and welcome to my talk, SQL Injection A History. In this talk, I'm going to go over three main things. The first one is a brief history on the origins of SQL injection. Then I'm going to talk about how guidance for defending against it has shifted through the ages. And finally, I'm going to talk about why these SQL injections are not a common finding in pen test reports anymore. So, a little bit about myself. My name is Will McCardell. I was a software engineer for a number of years, then a database administrator, and now finally I'm an application security engineer at a security consultancy in Milwaukee called SysLogic. When I was thinking about what topics to give for this talk, I realized that I could probably speak on all three things I've done so far with SQL injections. So here we are. So, who here has been a part of a data breach? You're just not aware of it yet. Data breaches are a common occurrence these days, and one of the primary causes for them, especially in the past, was a SQL injection. Attackers would break into websites, dump the users table, and then put the information on the dark reaches of the internet. They were so common, in fact, that the website Have I Been Pwned, which is a website that collects a number of data breaches in the dark web and other places that get sent to them, collates them, and allows you to look up your usernames, emails, phone numbers, etc., to see which data dumps you've been included in, actually has a SQL injection as their logo. You see that on the top left, and also the giant thing on the screen you've all read already. So, what is SQL injection? SQL injection is a vulnerability or weakness in an application where an attacker is able to modify user-controlled input to get the application's database queries to behave in ways that the programmers did not intend to do so. This is almost always done if the programmers chose to do what was called dynamic SQL generation with string concatenation, where they are jamming multiple strings of characters together to create the database queries and then sending those on. So why would you do SQL injection? Well, it's a lot of fun, but you can also do a number of other things. For example, you can extract all database data. You can wipe or subtly modify data in there in case it's a competitor. You can do reconnaissance to try to figure out the structure of the application behind the scenes so that you can do more tailor-made attacks to penetrate deeper into their systems. You can use it to establish lateral movement beyond a number of the defenses because you are executing code that you wrote on their database servers, which are usually fairly deep into defenses. Rocky. In the late 2000s, it was very important to have a really blinking MySpace page. And the Rocky was a middleware that sat on top of the MySpace pages, your Facebook pages, etc., and doing a number of special plugin-like behaviors to modify show photos, etc., or glitter text, as you can see in this example. Why they're relevant to this talk is that in 2009, they suffered a data breach, which affected 32 million of their users, which was all of them. And in this data breach, the attacker who found this determined that all the passwords for the users were in plain text. And this was a boon to security researchers because they finally had a list of many people what they actually used for passwords. There were a lot of ones that still are used to this day. You can see a list on the right-hand side here briefly, but security researchers were also able to determine that of the 32 million passwords they had, only 18 million of them were unique. So almost like 40% of the passwords was duplicates found elsewhere in the database. And Rocky is still actually used to this day. The password list is a common thing that's reached for by penetration testers, hackers, attackers of all stripes. If they need to log into a web page, they'll send in a number of usernames with the RockU password list after that. It can also be used for cracking password hashes. For example, up on the screen here, we see a command running hashcat passing in the RockU database list, password list, and it is able to crack a number of the passwords hashes in there. So, how to do a SQL injection? The primary way is you send a single quotation mark into a user-controlled input. And what that means is an input field that the user is able to modify. It could be a username field. It could be the password field. It could be an order number field, your mother's maiden name field, etc. Could also be something like an API endpoint or a HTTP header, etc. And the first thing you do is reach for the single quotation mark. If the application is vulnerable to SQL injection, this is likely to cause an error of some sort. So you send this in and you look for unexpected behavior. An example of that is this web login page, where we see the email has been changed to just be a single quotation mark, and then the password is also a single quotation mark, but you can't see that. We then log in, and we then see this object pop up. I don't know what object means. However, it's not what they intended, almost certainly. So that means this is probably weak to SQL injection. So the next thing that people usually reach for is a set of other strings to see what exactly they can do with the SQL injection they found. A fairly common one is this one: single quotation mark or 1 equals 1, semicolon dash dash. And what this basically does is it does the single quotation mark, which closes off the injection point inside the database query. And then it adds or 1 equals 1 to it, and then politely terminates the SQL query with a semicolon. And what that is doing is the database query is then going to check for every piece of data in all the tables it has access to. It's going to check to see, does 1 equal 1? And since that's usually true, it's going to essentially return all the data inside the table. And then after that, we see the dash dash at the end, and what that is doing is telling the database to ignore all the other parts of the query that were originally inside the database query after that, because the dash dash is commenting that code out. And that's the way to cause SQL injections to not cause errors. So we see an example right here with that as the login, meaning the email, and then we're going to go to login, and we see that we are the admin on the juice shop, which is great, because then we're in. There are other things people reach for. For example, in 2013, during anti-government protests in Turkey, hacktivists called Red Hack were able to break into a utility website for the state government, and they were able to delete a number of bills owed to the utilities by the citizens. And after they did this, they posted on Twitter the login, how to break into it so other people could mess around with the system. And what they say here, as you can see, is single quotation mark or single quotation mark equals single quotation mark. And that's quite the mouthful. But what add is essentially doing is it's going to check to see if the concept of empty string is equal to the concept of empty string. That is true everywhere. So that's allowed them to bypass the authentication for this website. So the first publication for SQL injection was in the magazine Frack. I assume some of you have heard of that. In December 25th, 1998. This was an article called NT Web Technology Vulnerabilities, and it went over a number of vulnerabilities found in the latest Microsoft code. And the author of it was this gentleman, Rainforest Puppy, also known as Jeff Forrestal, who, as an interesting note, he was also the very first person to release a template for responsible disclosure of vulnerabilities in applications. So in the article, he also offered what Microsoft said was definition of SQL injection. Not a problem. He and his co-researchers talked to Microsoft beforehand, before publishing the article in Frac, and Microsoft's response was essentially that this was not a problem that he had to worry about, and that they were not going to fix it. They were very wrong about that. And in the rest of the article, he explains not only how to do SQL injection, as you can see here. The very bottom query here is actually the first SQL injection ever publicly listed. Select star from table where x equals 1, and select star from sysobjects. And he explains the benefits of doing SQL injection, how common you can see it. For example, he had to explain that by doing SQL injection, you don't need to know anything about the database. You don't have to know the host name of it, the username, the password, etc., because you're essentially smuggling your code into their database. And it's interesting that that's brought up because it indicates that that's a novel concept. Just the concept of not needing to go through the defenses and just like smuggling your code through the rest of the application. He also talks about what you can do if your SQL injection that you found isn't returning any data, or it's not going to display to UI. And he essentially says that you can use the built-in features of SQL Server to email yourself the queries that you're writing. And at the very end of it, he offers guidance for how to prevent SQL injections. The first thing he says is to escape the user-controlled input, and then also, better yet, use custom stored procedures. The first thing he suggests is to escape the user input. And by that, he means specifically wrap the entire input that the user sends in double quotation marks. And then if there's any single quotation marks in the input, you should double them up so they're double single quotation marks. And essentially what that does is it gets SQL to, I see you taking photos, don't do that. It gets SQL to treat them as if it's not actually going to modify the query itself. And the reason why I said don't take photos of this one is because you should not do this. This is the last resort for stopping SQL injections. It is finicky, it is likely to break, it is highly database specific, and it is not recommended. But it was the second best thing they had at the time. What he said he should do is also use custom stored procedures. Stored procedures are pieces of code that get shipped into a database by the programmers. And what's interesting about them is that the stored procedure has the query portion set in stone ahead of time. Once you create the stored procedure, you are not going to be able to modify the structure of the query, and that is what the defense against SQL injection is. SQL injection is trying to modify the structure of the query to get it to act in ways that the developers did not intend. So by having the stored procedures here already shipped into the databases, it is not something that can have SQL injection done against it. And he did say to use the parameters functionality of this, and that doesn't have the arrow here, but it's the cs.setString1 custname. What that is essentially going to do is send in a customer's name as data specifically, not as part of a query. So he had that one right. And that was 1999, essentially. 2 years later, this organization came into existence, OWASP, Open Web Application Security Project. They worked for a number of years to provide guidance for how to test applications for SQL, for all sorts of web application security problems, including SQL injection, as well as guides for how to defend against them. And in 2005, they released a guide at Black Hat called A Guide to Building Secure Web Applications and Web Services. They offered 4 pieces of advice here. Parameterized stored procedures, and that is echoing Rainforest Puppy's top recommendation. Then prepared statements, ORMs, for example, Hibernate. Those are object relational mapping systems. And then dynamic queries with escaping user input. So, parameterized stored procedures. We've already talked about these. Just going to skip that by. to prepared statements. Prepared statements are very similar to stored procedures, except instead of shipping the code into the database, it's going to be stored in the application. They also do something where you are setting the query portion of the query in stone, and then you are sending in the separate data points to be modified. So you can see that here in the second line of code, string query equals, and that is essentially setting the query portion in stone. The next line is preparing the statement and telling SQL this is the query part. Anything else you see after this point is not going to be part of the query and cannot modify it. And then finally, we're seeing inserting the cust name there. Object relational mappings, I'll go over that in a bit, but right now you just need to know that they are basically auto-magically bind the application's object data to the database's representation of that same data. So for example, in this right here, you see that we see a SQL query that a programmer would normally have to add to an application, but if they were using an ORM system, all they have to do is take the cat's name and modify the object for that cat, I guess. And that would automatically flow down into the database. And finally, they say if you need to, you can do dynamic SQL queries with escaping user input. Then in October 2007, the most important piece of guidance for SQL injection prevention came out on the security blog XKCD. Little Bobby Tables. Little Bobby Tables is one of, by far, the most popular XKCD comics out there, and it was one of the first ones to really go viral in the programmer blogosphere. It is still heavily referenced. I think it's a legal requirement to mention it during presentations on SQL injection, and it has gone a long way to educate people about what SQL injections are, what their impact is, and also how you can fix them or prevent them. Fast forwarding to this year, we see new OWASP guidance for how to prevent SQL injections. So now the first option they say to do is to use prepared statements with parameterized queries. This is interesting because it's now #1 recommendation versus #2 that it was in 2005. Now they are recommending the use of properly constructed stored procedures. We'll get into why that verbiage changed a little bit later. And then they offered a new option called allow list input validation, which is an interesting approach. And finally, they say escaping all user input. So prepared statements are #1. These are going to be highly recommended these days for one of two main reasons. One, stored procedures are a pain for other people for developers to deploy. They cause a lot of headaches, and it's generally not seen as worth the pain these days. So that's one of the reasons. The next one is that stored procedures don't actually prevent SQL injections. Previous guidance almost made them seem like a magic shield that as long as the code was inside a stored procedure, it was preventing SQL injection, and that's not the case. And that's why it's called properly constructed stored procedures now. The main way to do SQL injections is doing the dynamic SQL queries with string concatenation, and those are still things you can do in stored procedures. I've seen far too many of that. So the call out now is properly constructed stored procedures, and they are explicit in their recommendations to not do dynamic SQL queries inside the stored procedures unless absolutely necessary. And to use the parameterized version, and that's essentially where you have the data points explicitly called out for what can be modified, and SQL knows that they cannot modify the query itself. Next up is allow list input validation, which is a new one. And it is essentially in the situation where you need user input to be modifying the database query structure somehow. This could be like if you have a table that swaps out in a query based on user input, or if you want to change the sort order in some kind of table view from ascending to descending. And they say that in this situation, you should take in the user input that would normally cause this and check it against an allow list. And then instead of sending in the user input, if it passes the allow list, send in another value that is not related to the user input. And this way is a way to prevent the user input from actually reaching the query and putting up a wall there. They also recommend this as a secondary line of defense for any of the other types of SQL injections, prevention strategies. And they do end by saying that if you do have to use this, you should seriously consider re-architecting your application because this should not happen in a good code base. So after they recommended re-architecting your system, they say to option 4 is dynamic queries with escaping input. They are explicit, this is only as a last resort when none of the other ones are feasible. This is a frail methodology that's likely to break. It's very bug-ridden, and there's a lot of research on how to bypass this sort of thing. And also, because of all these things, they cannot guarantee the prevention of all SQL injections. You can kind of imagine the dynamic queries with escaping input is like putting up a chain link fence around a query to prevent people from getting in, and just checking to see if they have like special characters in the data. Whereas doing something like prepared statements, instead of a chain link fence, it's a stone wall. You're probably not going to be able to get through that, whereas a chain link fence, there are ways through it, or at least much cheaper ways. So, I mentioned earlier that penetration testers are not seeing SQL injections as often anymore. They have become a bit of a rarity, and there were a number of reasons for that I'm going to go over here. So first was developer knowledge. They've been around for like 20 years at this point, 23 years. OWASP has existed for a lot of the time. They have been very vigilant about teaching people about this. Developers are now sharing the strategies, etc. We also saw the rise of the object relational mappers. These are now basically the default way of interacting with data. They're extremely easy to use, and unfortunately the security aspects of them are basically secondary to why developers use them, but it's a happy coincidence that they prevent a lot of SQL injection by not requiring writing your own queries. Next was WAFs, web application firewalls. These basically sit between the end users and the applications that they are running, and they prevent any attacks that they try to prevent attacks based on pattern recognition. These were actually first mentioned in PCI DSS in 2004, so they were already pretty popular back then. And they were popular because they were a way to bolt on a layer of security to applications you couldn't actually modify. For example, if you bought some functionality. The growth didn't really explode until the cloud came out, at which point it was essentially a checkbox to enable it. And that gave you a pretty good set of rules until it caused a production outage and they turned it off in frustration. Moving on, microservices. Microservices was a new architectural pattern for database software architecture that started in the 2000s, 2010s. And instead of having one giant application, one huge database behind it, where the order history table is right next to the user preferences table, we instead have a number of small applications, each with their own databases. And what this is going to do is, because the user's preferences database is in tables in a separate database and the order history, it prevents the access from reaching it. So this is essentially enforcing architecturally the principle of least privileges, and this limits the blast radius of SQL injection. NoSQL came into being. I'm not going to talk about that. So disappearance of SQL injection came up for these reasons. NoSQL did have a rise in popularity, so there was just less of that for that reason. And there is one last question, though, and that's actually if SQL injections did disappear. The organization MITRE keeps track of the CVE database, common vulnerabilities and exposures, which lists all the software security vulnerabilities in applications. And as part of this, they did a report in 2022 to see what was the most common weaknesses found in these things. And SQL injection was 3rd place. And this was actually up from 6th place. So why aren't pen testers seeing this anymore, and why is this still the 3rd most common vulnerability found in the CVE data set? I think it's because of a number of reasons. One is that the SQL injections and the pen testers' view of them, the pen testers are testing more modern applications, generally speaking. This would be modern software as a service things that aren't going to be reflected inside the CVE data set, and it's going to be more or long-lasting applications that have had many years to fix all their SQL injection vulnerabilities in them. We also see a divergence in what the pen testers are doing versus what's in the CVE data set, which is going to be mostly like open source libraries, products that you can upgrade, physical hardware products, or a number of other things of that variety that pen testers just aren't really looking at these days, partially due to economics. Companies getting pen tests are going to be either have more security mindset to think through these things and hopefully prevent them, or they're going to also have regulatory compliance they have to follow through that I'm very grateful for. So that was my presentation. If you have any questions, you should really consider asking OWASP first. They know a lot more than I do. But otherwise, I'll probably be over there after this talk. Thank you very much.